to write this linear equation, we need the y-intercept and the slope. So when I look at this graph, I'm going to go from left to right and find two lattice points that I can then count the rise and the run. So I notice a point here, and the next closest lattice point is right there. So for my rise and my run, I can go down 2, which tells us that our slope is going to be negative, since from left to right we're going down. So it's down 2 and over 1. So the slope is negative 2 over 1, which reduces to negative 2. And I also need the y value, or sorry, the y-intercept, the b value. So I'm going to look at the y-axis and see if I cross at a whole number. And since I do, I don't have to do any kind of calculation. The b value is just negative 1. So the equation of this line would be y equals negative 2x minus 1. So for number 2, given these 2 points, we're going to do the y1 minus y2. Or you can do y2 minus y1. Typically, you'll see y2 minus y1 over x2 minus x1. So given those 2 points, the second y value is negative 1, and the first y value is a half, so negative 1 minus a half. x2 is 15, minus x1 is 14. So then we can figure out that the numerator is negative 1.5, and the denominator is 1, and that reduces to 1.5. And then in your calculator, if you like to turn that into a fraction, you can. It's not a bad idea. That would be negative 3 over 2. Then to get the b value, I have to pick one of my original points to be the x and the y to then solve for b. So I'm going to choose 15, negative 1, just because there's no fractions. And I'm going to plug that into the y equals mx plus b. So we have y equals m, here is our m, times the x, which is 15. The x there was 15, plus b. Okay, and so now this, we need to do this multiplication. That's going to give us a negative 22.5. Then to isolate b, we can add the 22.5 to the other side. And that gives us 21.5 for b. So now we have m, we have b. We can write our equation as y equals mx plus the b we got, the 21.5. Okay, number 3. So we're going to be perpendicular to 9x minus 2y equals 15. Now, perpendicular lines have opposite and reciprocal slopes. In other words, you change the sign and you flip the fraction. Now this, we don't know what the slope is yet until we solve for y. So I'm going to solve for y by first moving the 9x, by subtracting 9x to the other side. Then I'm going to divide by the negative 2 to get y equals positive, because the double negative, positive 9 over 2x minus 7.5. And this actually isn't going to matter because the y-intercept of the perpendicular line is irrelevant. What we now know, though, is since we're perpendicular to this line with a slope of 9 over 2, our slope is the opposite, so negative, and then flip the fraction, negative 2/9. So that's the slope of our line. Now to find the y-intercept, we're going to use the fact that we have to go through the point 216. So now we can plug the y and the x and the m into the equation and solve for b. So we have y equals mx plus b. And now we can do some calculating. So this here is negative 4/9 plus b. Then we can spin move that, positive 4/9. Now that's this is negative 0.44444444. And if you want to do everything in decimal, you can. Just keep lots and lots of those decimals so your calculator can later turn that back into a fraction. So if we do this 16 plus 0.44444444, that gives us 16.44444444 equals b. And if we use our calculator for that, that'll turn it into 16 and 4/9, or it might give it to you as an improper fraction. Either way, that's the b value, 16 and a little bit. So the equation would be y equals negative 2/9 x plus 16 4/9. Okay, so for number 4, with word problems, my recommended strategy is to make a table given the information, and then we can go through our slope and y-intercept process from that table. So here we're comparing minutes to cost of the phone call. And here it looks like they just give us 2 situations or 2 moments in time. They tell us that a 5-minute call costs $5.91 and that a 10-minute call costs $10.86. So we didn't have to do much figuring out of the table. They gave us x's and y's. So now we can do our change in x, change in y. So we can do 10.86 minus the 5.91, and that's going to give us 4.95. And then 10 minus the 5 gave us 5. So our slope then is that change in y's divided by change in x, which is 0.99, which in the context tells us that it was 99 cents per minute. Okay, and now we pick one of these points to be our x and our y. I'm just going to choose this one here. Actually, I'm going to choose the top one because the numbers are a little bit smaller. So we have y equals mx plus b. So 591 equals 495 plus b. Then we can subtract the 495. So we get that b is 96 cents. In other words, you have a one-time fee of 96 cents. So the equation that relates the cost to minutes, or the cost given the minutes, would be y equals 0.99x plus 0.96. Okay, for number 5, we're parallel to the line y equals 2x minus 8. So what we know about parallel lines is that they have the same slope. So if we're parallel to this line, and this slope is 2, the slope of our line is the same, so it's also 2. And now our line has to go through the point 72, so we can use that x and y to then solve for the y-intercept. So we can say y equals mx plus b. So y equals 14 plus b. Move the 14 over. So b equals negative 12. So here the equation is y equals 2x minus 12. Okay, number 6, let's go back here. All right, so we have a graph. So to start with slope, we want to find 2 lattice points. Looks like we have a lattice point there, and the next one would be here. So now we can count our rise and our run, again, left to right. So it's down 1, 2, 3, 4, and over 3. So the slope of this line is negative 4/3. And now the y-intercept, we have to be careful. So here, that doesn't go through a lattice point, so we can't, we need to calculate. We can't just say, oh, it's about 3.2 or 3.5 or whatever. We need to, in this case, calculate b. And to do so, we need another point. We need an x and a y. Well, on this graph, you can choose this point, you can choose this point, you have another point there. You can pick any one of those x and y's to help find the b. I'm going to choose this point here. It has an x of 1 and a y of 2. So x is 1, y is 2. So I'm going to plug that into the equation, the y equals mx plus b, to then solve for b. So we have y equals mx plus b. So 1 times 4/3 is 4/3. We can then add the 4/3. So we get that b is, now if you do this in your calculator, you can get 3.3333333333. And for what it's worth, any kind of repeating 3's is a third. So 3.33333 is 3 1/3. Now, this number makes sense because if we look at our graph, that is where our line seems to be crossing. So it's a good chance our calculations were correct. So our equation then would be y equals negative 4/3 x plus 3 1/3. Okay, number 7. So here we're going through 3, -2, and 4, -2. So one thing I haven't mentioned on the previous problems is that before we start going through our process, we should check to see if it's one-dimensional, meaning do the x's not change or do the y's not change? Because if something doesn't change, it's one-dimensional. So here, 3 changes to 4, but -2 stays -2. So this is just a one-dimensional equation. The y values remain constant, so the equation is simply y equals -2.